Have you ever looked up at the sun and thought you knew everything about it? This giant, blazing ball of gas warms our planet and gives us light. But what if I told you there are parts of the sun that are almost a complete mystery to us? Vast, uncharted territories that hold secrets we're only just beginning to guess at. Today we're journeying to the most enigmatic places in our solar system, the poles of the sun. For decades we've sent probes and telescopes to study our star. We've mapped its surface, analyzed its flares, and tracked its sunspots. We've sent spacecraft, like the Parker Solar Probe, to literally touch the sun's atmosphere, and the Solar Orbiter to get a closer look than ever before. Yet, despite all this incredible technology and effort, there's a huge piece of the puzzle we're missing. No mission has ever flown directly over the sun's north or south pole. It's like trying to understand the Earth without ever having seen the Arctic or Antarctica. Why is this such a big deal? Well, these polar regions aren't just empty, quiet areas. Scientists believe they are the key to understanding one of the sun's most dramatic and powerful phenomena, the solar magnetic field reversal. Imagine the Earth's magnetic poles flipping. North becomes south, and south becomes north. It sounds like science fiction, but this happens on the sun approximately every 11 years, marking the peak of what's called the solar cycle. This cycle drives everything from the number of sunspots on the sun's surface to the frequency of massive solar storms that can hurl plasma and radiation across the solar system. These storms, known as coronal mass ejections, can have a real impact here on Earth. They can disrupt our satellites, knock out power grids, and create spectacular auroras, far from the polar regions where they usually appear. Understanding the solar cycle is crucial for protecting our technology and even our astronauts in space. And where does this epic magnetic flip begin? All signs point to the poles. It's thought that deep within the sun, a complex dynamo process generates its magnetic field. This field is then transported to the surface and carried towards the poles by vast currents of plasma, like giant conveyor belts. When this old magnetic material reaches the poles, it sinks back into the sun, and new magnetic fields emerge with the opposite polarity. The poles are the place where the old cycle dies, and the new one is born. Without a direct view, we're trying to piece together this process from sideways glances. It's like trying to understand a whirlpool by only looking at the edge of the water. We can see the effects, but we can't see the engine driving it all. A mission that flies over the poles would give us a bird's-eye view of this incredible process for the first time. We could watch as magnetic fields converge, cancel each other out, and re-emerge, finally confirming or challenging the theories we've spent decades developing. But the mysteries don't stop there. The sun's poles might also hold the key to understanding long-term climate change on Earth. We know the sun's output isn't perfectly constant. Over centuries, it goes through longer cycles of higher and lower activity. For example, the period from 1645 to 1715, known as the Maunder Minimum, saw a dramatic decrease in sunspots. Coincidentally, this period overlapped with the Little Ice Age, a time of colder temperatures in the northern hemisphere. Is there a direct link? The scientific community is still debating the exact relationship between solar activity and Earth's climate. The sun's total energy output only changes by a tiny fraction, about 0.1%, during its 11-year cycle. However, some scientists believe that the magnetic field, particularly its strength at the poles, could be a better predictor of long-term solar activity. The strength of the polar fields at the end of one cycle seems to predict the intensity of the next one. If we could measure these polar fields directly and consistently, we could potentially forecast solar activity not just 11 years ahead, but decades into the future. This would be a game changer for climate science. It would allow us to better distinguish between natural climate variability driven by the sun and human-induced climate change. Having a reliable long-term forecast of solar activity would give us a much clearer picture of our planet's future climate. So, what's stopping us from just sending a probe over the sun's poles? Well, it's incredibly difficult. Orbital mechanics are a major hurdle. Everything in our solar system, including Earth, orbits the Sun on a relatively flat plane called the ecliptic. To send a spacecraft over the Sun's poles, you can't just launch it straight from Earth. You need to perform a massive change in its trajectory, essentially flinging it out of this flat plane. This requires an immense amount of energy and a very clever flight path. The Ulysses mission, a joint venture between NASA and the European Space Agency launched in 1990, gave us our best look so far. Ulysses used a gravity assist from Jupiter to swing itself into a high-inclination orbit that passed over the Sun's poles. However, it was still at a great distance, and its instruments, while groundbreaking for their time, are now decades old. More recently, the Solar Orbiter, launched in 2020, is gradually increasing its orbital inclination. Over the next few years, it will give us our best views yet of the polar regions, getting closer and taking higher resolution images than Ulysses ever could. But even the Solar Orbiter won't fly directly over the poles at a 90-degree angle. It's a huge step forward, but the ultimate prize, a true polar orbiting solar observatory, remains a dream for now. Imagine what such a mission could reveal. We could see the so-called polar crown filaments, which are huge arcs of plasma that ring the poles. We could watch the formation of polar plumes, long, thin streamers of solar wind that gush out from the Sun's open magnetic field lines. These polar regions are the primary sources of the fast solar wind, a stream of particles that travels at nearly 2 million miles per hour. Understanding this fast wind is crucial because it fills the entire heliosphere, the bubble that surrounds our solar system, and affects conditions all the way to its edge. A dedicated polar mission would solve fundamental questions about our star. How does the Sun's internal dynamo really work? What is the precise mechanism that triggers the magnetic field reversal? How does the solar wind accelerate to such incredible speeds? And can we use the polar magnetic fields to reliably predict solar cycles and their impact on Earth's climate for generations to come? The Sun's poles are one of the last great frontiers of solar system exploration. They are a puzzle waiting to be solved, a blank spot on our map that is tantalizingly close, yet incredibly hard to reach. The secrets locked away in these regions are not just academic curiosities. They have practical implications for our technology-dependent society and for our understanding of the long-term future of our planet's climate. As missions like Solar Orbiter inch closer to giving us a better view, the excitement in the scientific community is building. Every new piece of data is a clue, bringing us one step closer to solving the polar region puzzle. It's a testament to human curiosity and our relentless drive to explore, to understand not just the worlds around us, but the star that makes our own world possible. Thanks for joining me on this journey to the mysterious poles of the Sun. If you found this as fascinating as I do, don't forget to hit that like button and subscribe for more deep dives into the wonders of our universe. Let me know in the comments what you think the biggest secret hidden at the Sun's poles might be. See you in the next video.